Hello class, today we're going to talk about solving multi-step equations. So now that we've learned how to solve a simple equation, we're going to use the ideas of opposite operation to continue solving equations. But sometimes it's not just one step, but there are multiple steps. So here are some kind of tips that you can use when solving multi-step equations. First, what you want to do is make sure you get rid of any brackets. Okay, and we do that by expanding or using that distributive property that we used in the past, but we'll practice again in the next class. And then what you want to do next is collect the variable terms on one side. So bring any, and there might be more than one variable in the equation, and your one variable term, sorry, and you're going to bring them together so that they're on one side of the equation. On the other hand, we want to keep all the constant terms, and those are the terms without any variables, and put them to the other side of the equation. And then what you can do once you have variable terms on one side, constant terms on the other, you're going to collect them, put them together, and the whole idea is to isolate the variable so that the variable is by itself, no coefficients at the end. And what you always want to do when you solve any equation is don't forget to check the solution to make sure it makes sense. So let's look at an example here. Here we have 3x plus 2 equals 2x minus 4. So we have multiple variable terms. We have a 3x and a 2x. So we want this 2x to be with 3x on the left side. And then we have this constant term of 2 and a negative 4. So we're going to bring that positive 2 on the other side. So we're going to do that by doing opposite operation. So this 2x, if we want to move to the other side, we've got to get rid of it from this side, so we subtract 2x. We do to one side, you do to the other. So then these 2x's will cancel, but there's a negative 2x now on the left side, which brings down to just simple x when you collect that. On the other hand, for positive 2 that's on the left side, we want to bring it to the right side so that it's away from our variable so we can isolate it. So a positive 2 on this side means we're going to subtract the 2. Those two terms are same value, opposite operation, so they cancel out. And then we have negative 4 minus 2, so x is equal to negative 6. So try out a bunch of these questions. I've done 2 here so that you can see 2 examples done. I have 5q minus 8q. This one actually comes from, this equation here. 5q minus 14 equals 8q plus 4. Our variable terms are here and here, so we're going to bring it over on this side. So when I bring it to the other side, it becomes the opposite sign. So a positive 8q over here would be a negative 8q on this side, which is contrary to the negative 14 and the positive 4. I'm going to bring that negative 14 to this side, so it becomes a positive 14. So when I collect my terms, 5q minus 8q becomes negative 3q. 4 plus 14 becomes 18. I need to isolate in the end. I just want the q by itself, so I got to get rid of the coefficient of negative 3. So I divide this side by negative 3. What I do to one side, I do to the other. So 18 divided by negative 3 produces negative 6 is my q. Here's another example from H. Negative 5 minus negative x equals 4x plus 1. My variable terms are here and here, but before I start collecting them, remember the very first step is to try to get rid of brackets. So I'm going to get rid of this bracket first by applying that negative inwards. The negative inwards changes the sign, so it becomes a positive x. And so there are my variable terms. I'm going to bring it actually to this side. It doesn't matter which side I choose, I just need to choose a side. And I'm going to bring this one over because then I know that this has more x's, so this will stay positive x on the right side. So 4x minus x becomes 3x. This now positive 1 and the negative 5 need to be collected on the left side now. So I'm going to bring that positive 1 over. So it becomes negative 1, and we still have that negative 5 in front. Okay. And so when I collect them, I get negative 6 on the left and I get 3x on the right. I need to isolate for just the x, so I'm going to divide out the 3 because right now 3 is being multiplied with the x. So I'm going to divide that out by 3 on both sides, so that my answer is negative 2 equals x. So remember that last point up above, Don't forget to check your solutions. Well, we do a check on our solutions by doing what we call a left side, right side check. So if I know now that my answer was q equals -6 from this question and x equals -2 on this question, how do I check to make sure if that's a valid answer? Well, I rewrite the original equation down here, and I'm going to draw this line right in the middle down the equal sign. And instead of doing all this procedure that we did earlier, which is to solve and find out what q is, I already know what q is now. So all I'm doing is just checking to see if the left side equals the right side. So the left side of the equal sign was 5q minus 14 in the question. On the right side of the question, that's the original question that's up here, I have 8q plus 4. And that lines right through the equal sign so that it kind of helps you remember to not bring things over the equal sign, not like solving an equation. We're just checking if the left side is equal to the right side. So I'm going to plug in -6 into my q. Here it is. And so every time I see a q, I'm just plugging in as -6. And here, 5 is being multiplied by q, so it ends up being 5 times -6, which is -30. And I still have that -14, so the left side equals -44. On the right side, there's my q. So every time I see a q, I substitute that with -6. The 8's being multiplied by the q up here in the question, so 8's being multiplied by -6 here, plus 4, so it becomes -48 plus 4, which ends up being -44. So my left side value was -44, my right side value was -44, so therefore I've just checked that q is equal to -6 in this question, or this question here. Therefore I just write concluding sentence of therefore left side equals right side. I do another similar one here with x equals -2. The original question was up here, so I rewrote here, drew my line down the equal sign, and then I just substitute wherever I see an x as -2. And note that here x is -2, so that's just -2, but there's still that negative in front here. So that stays over here in front. Over here, there's an x, so I put that as -2. That gets multiplied by 4. And when I work it out, the left side equals -7. The right side equals -7. So left side equals right side. Therefore, x is actually -2 for this question. So I've just done that to check. Here's some terminology to help you in case you want to make sure that you hear different versions of the words. Inverse operation is the same thing as saying opposite operation. So instead of +4, it's a -4, or +4 is subtract 4. When you hear the words variable term, it means a term that has a variable in it. So for example, 2x or x over 3 or 1/2 x or -x or -2x, just wherever there is a variable in the term. A variable, remember, is just a placeholder for a value that we don't know, and it's represented by a letter. Eventually, when we solve an equation, we find out what that value is, and that's the whole point of solving an equation. A constant term or a constant is just a number term, no variables attached to it. Okay, so it's like that +4, -1, 110, -50. It's just the number, no x's, no letters attached to it. So to summarize, to solve an equation means to find the value of the variable that makes the statement true, that makes the original question equation true. To solve a one-step equation, we just isolated the variable by performing the opposite operation. And that's what we learned last time. And now in two-step or multi-step, we're going to what we do more is isolate the variable term and then isolate the variable. So the whole idea is to get the variable by itself. No terms added, subtracted to it, no coefficients being multiplied or divided with it. We just want to isolate the variable. And then what you should always do at the very end is to make sure you check a solution by substituting that value back into the equation. Root's just another word for value, and we do that using the left side, right equals right side check, okay? Just kind of a little tidbit of information. When we isolate variable, we are actually performing BEDMAS in reverse because we're trying to kind of just isolate the variable and not simplify. So here's the BEDMAS acronym that we always use. In the past, when we've asked you to evaluate or simplify an expression, we follow BEDMAS. Like I want to find out, for example, 3, and then it was x plus 2 minus x plus 5, and we distribute, and we just simplify it. And so we always follow BEDMAS, so we do brackets, we'll do exponents, and we do addition and subtraction, anything like that. Or sometimes when you plug in a value, so when we did the q equals -6, and we say 5q plus 1, so we would just evaluate, so we do 5 times -6 plus 1, so then you're -30 plus 1, so you end up with -29. So this is evaluating. So we always follow BEDMAS. We did multiplying before addition. And so we followed BEDMAS for that. But now, when we're solving an equation, we're doing the opposite. We're undoing everything. So we're doing the addition and subtraction first, then multiplication, division, and then exponents, and then brackets, okay? So to solve an equation, we're actually doing it this way instead of valuing and simplifying, okay? And sometimes you might hear me say that when we're solving an equation, we're actually doing SAMDEB, which is just BEDMAS backwards. All right, good luck, and have fun.